Okay, so we are to Unit 4, Lesson 1. In this unit, we deal with transformations. And transformations are taking points or collections of points and moving them around in the coordinate grid usually. Transformations don't always happen in the coordinate grid. We are going to apply some rules of transformations in the coordinate grid. So I think the easiest transformation to learn is a translation. And a translation is a transformation where you are shifting points around or you're shifting shapes around. So one way to show a translation is through a vector. So a vector it looks a lot like a ray, but a vector is something that has magnitude and direction. So when we talk about vectors, they always have a starting point or an initial point. In this vector I show you, the initial point is P, and it has a terminal point or an ending point, and that point for this is Q. So the vector is named PQ because it follows P to Q. So the horizontal component of this vector is 5 units right. So the horizontal component is 5. The vertical component is 3 because the translation is right 5, up 3 as a shift. So the way we would write this vector in what's called component form, and that's going to be important later on, is those brackets and the numbers 5, 3. So it looks kind of like a coordinate pair, but this really means to move right 5 and up 3. So in example 1, identifying the components of a vector, I look at j to k, and if I count from j to k, I know that I go right 1, 2, 3, and I go up 1, 2, 3, 4. So the vector, first of all, is the vector from j to k, and I use that arrow to indicate j to k. And component form, I use these brackets, it would be 3, 4. I went right 3 and up 4. So if I went down or to the left, that would be a negative component. So when we talk about transformations, transformations have a new figure called an image. The original figure is called the preimage. So a transformation is a type of function that moves or changes a figure in some way to produce a new figure. That new figure is called the image. Another name for the original image or the original figure is the preimage. So the preimage are the inputs, the image are the outputs. So when we talk about showing this on a graph, on a grid, we have vertices of a triangle ABC. A is at 0, 3. B is at 2, 4. And then C is at 1, 0. So this is what we call our preimage, ABC. And we are going to translate this using the vector 5, -1. So what this vector really means is right 5, down 1. So I take each of those points and I move them right 5 and down 1. So for point A, right 5 would be 1, 2, 3, 4, 5, down 1. Our new A value would be right here. And I use A with an apostrophe. We call that A prime. That is our image of A. Our image of B, right 1, 2, 3, 4, 5, down 1. That's the image of B. C, right 1, 2, 3, 4, 5, down 1. That's the image of C. So my image is in blue. I went right 5 and down 1. So it's being able to read that component form to find the image from the preimage. So next, writing a rule. Now I'm going to show you how to write a rule using algebra. So first of all, I'd want to count. So the image on the right is the preimage. The image on the left is the image. So this really goes, and I'll use green for this one, to show left 1, 2, 3, 4, up 1. So I would say left 4, up 1. That's a verbal description. Now a rule would take our original points, our original xy points, and transform them. So we'd always write xy, and then this arrow, and then to show this, moving left 4, I took my x values and I subtracted 4 from all of them. To show up 1, I took all my y values and I added 1 to them. So that would be the rule for this transformation. Okay? It was left 4 up 1 to reverse that. So another example. In this one, it's already graphed for us. So it's really just knowing how this gets transformed. So what this transformation means, I'd like us to just translate this into words. So this would mean right 3, down 1. So if I was going to show this, right 1, 2, 3, down 1 for all of these images of these points to graph our image. New A, new B, new C, and new D. Okay? So this one was already graphed, but it's just understanding and showing an example of applying a rule. So you'd graph the points, you'd follow this rule. So the last thing I want to show you is this guided practice. So I'd like you guys to take a minute, pause the video, and work through these so that you can move on to the next step in the lesson. Okay, so to explain the guided practice, number 1, you'd name that vector BK because it's pointing from B to K. And I counted, it went left 5 and up 2, so my component form was -5, +2. In number 2, the vertices were 2, 2, 5, 3, and 9, 1. Using this vector, I subtracted 2 from my x values, and I added 6 to my y values. So I got 0, 8, 3, 9, and 7, 7. So it's just knowing to subtract from the x values for this one, add to the y values. Example 3, if we go back and we look at example 3, I would just say right 4, down 1. So that would be the rule, x plus 4, y minus 1. And it's important we know how to write that rule and read that rule. And then number 4, graphing the points and shifting them all right 1 up 2, doing that for all the points. So right 1 up 2 for all the points. And it's important to show R, T, R, S, and T. It's important to label those points so I know, if I'm grading this, what the image is and what the pre-image is. So the final thing we're going to work on is performing compositions. So compositions are multiple transformations happening at the same time. And all of these transformations we've talked about so far are rigid motions. And a rigid motion basically means that whatever gets transformed, it doesn't change the size or the shape of the object. Okay? A rigid motion is also called an isometry. So these are isometric, meaning they do not change. Okay? So we're going to handle a composition, and I'm going to explain kind of a shortcut to handling these compositions. Okay, so to perform this composition, you're doing 2 translations. You're going right 5 and then down 2, and then you're going left 4 and then down 2. So the way I would do this is I would rewrite this as one single transformation. So that means if I went right 5 and then left 4, that would really mean I actually went right 1. If I went down 2 and then down another 2, that would really mean I went down 4. Okay? So if you graph all your points, -8, 5 is R, -6, 8 is S. I'm going to draw that as a segment. We're only translating 2 points. And I'm going to use this single transformation. Right 1, down 1, 2, 3, 4. Right 1, down 1, 2, 3, 4. So R, S. And that's the image. Oops, not the straightest line there. Okay, so write it as a single composition. So what I'm going to do, I'm going to have you work through the guided practice, and I'm just going to show you my answers and then have you check your work with me.